So you've got your MISP instance up and running, things are going well, but how do you make that intelligence actionable? Let's explore how to export IOCs from your MISP instance to defend against the latest threats. Hey guys, welcome back to the channel. If you're new here, my name is Adam, and I love everything about cyber threat intelligence. I've helped build CTI teams, refine processes, and train clients on best practices. I've also built and managed various MISP instances to help organizations collect, analyze, and distribute threat intelligence. In this video, I will show you the best way to export IOCs from your MISP instance so you can share them with your security tools for detection and threat hunting. Once you have your MISP instance up and running, you'll want to start exporting the IOCs you have put into the platform and add them to your detection tools. MISP is designed to hold all types of cyber threat intelligence, from strategic to operational. One of the fundamental benefits of cyber threat intelligence is the consumption and distribution of indicators of compromise, or IOCs. They let you proactively defend your environment from the latest threats. This is operational intelligence. You can create detections from this intelligence to alert you when one of your hosts connects to a malicious domain, or you can hunt for a hacking tool in your environment using a tool's file hash. You can even automatically block known malicious IP addresses from connecting to your network. All of these measures, whether they fall under threat hunting or detection engineering, are the most basic way to defend against cyber threats, and you need to be utilizing them. You need an easy way to consume, analyze, and distribute IOCs to do this. You've already seen in this series how to store and consume IOCs using MISP events and feeds. The final piece of the puzzle is learning how to distribute these IOCs effectively to your security operations team to defend your environment from the latest threats. Let's examine how you can distribute IOCs by exporting them from your MISP instance, first using the web interface and then through the powerful MISP API. The simplest way to distribute IOCs using MISP is to export them using the web interface. Navigate to the export page under the Event Actions menu. The export page lets you download all your MISP instances attributes, or IOCs, in various formats listed under the Type column. To download IOCs, click the Generate button under the Actions column to create a list to download. You will see this happening as the progress field displays adding. Once the progress field displays queued, you can select the download button to download the IOCs in your chosen format. You can then view the IOCs once a download is completed. Here I've downloaded the IOCs in CSV format, but you can use JSON, XML, or even sticks. You can search each IOC group by its associated event. You now need to parse the data to extract the IOCs and upload them to your security solution for blocking or detection. You can also download specific IOC types by selecting them from the attribute types at the bottom of the page. The web interface method for exporting IOCs is clunky and slow. It requires you to log into the web server, manually choose which IOCs you want to export and in which format, and then parse the output to extract IOCs. This method is not ideal for modern security operations teams that need to move fast and optimize for efficiency. In fact, this method is considered deprecated by the MISP project and will be removed in the near future. The better way to export IOCs is through the powerful MISP API. This method lets you choose which IOCs you export, manipulate them using Python code, and adjust the format they are exported as, all programmatically. You can automate the entire process of pulling down IOCs and uploading them to your security solutions using the API. To begin with, you need to create an API key for your MISP instance. You will use this key to connect to the API and run the queries. Creating a key is easy. Go to Administration, list auth keys. Then click the Add Authentication Key button in the MISP web interface. You can then add the following code to a Python script to connect to the API. I've covered this code in a previous video. Just remember to replace the variables MISP URL and MISP key with the IP address of your MISP server and your API key. You can set SSL and debug to false to avoid any unnecessary errors when testing. I also recommend using an external Python file such as config.py to separate sensitive data like the IP address of your MISP server and API key from the Python script itself. This is important so you don't leak confidential information. You are now ready to use the MISP API to export IOCs. The MISP API object you created in the previous code block authenticates to your MISP server and returns a Python object you can use to perform API queries, such as adding and retrieving data. In MISP, attributes with the intrusion detection IDS flag set can be uploaded to IDS or other security solutions for blocking or detecting. It is these attributes that you will want to export as IOCs, which your security team can take action on. This is your operational intelligence. To export all attributes with the IDS flag set, add the following code to your Python script. This code uses the MISP object search method to do the following. First, it returns all attributes with the IDS flag set to 1, which is true, and then it returns a Python dictionary rather than the default JSON format as the output. You can now use regular Python code to interact with this dictionary of IOCs, parse out specific IOCs, and prepare this data to upload it to your security solutions. The data returned by the MISP API will be in a Python dictionary. However, you must do some parsing to get this data into a format your security solution can use. You have two options here. You can parse the data into a format that you manually upload to your security tool. For instance, you could parse it into text or CSV format, generate a file, and then manually upload this file to your security tool using its web GUI. Most security solutions allow you to bulk upload IOCs in text or CSV format. You just need to ensure you follow their file template to include the right data so the security tool can parse your list of IOCs and add them into its database. Another option is to use the security tool's API to upload your IOCs for detection and blocking automatically. This is a better option as it saves you time and is less error prone. However, your security tool might not have an API you can interact with programmatically. Let's look at how to do both of these options in code. To create a CSV file to upload, you first need to open a new CSV file to write your IOCs to. The following code creates a file named iocs.csv ready for your IOCs to be written to. In this demo, we will assume your security tool takes IOCs in the form of value followed by type, with the first row being a header row containing value and type as string values. First, import the CSV library into your Python script to create a CSV file. Next, we will define our field names in a list. We create a writer object so that we can write to the CSV file. This takes the field names we created in our Python list. Then we start by adding a header row. The security tool we're using takes a header row of type and value. Next, let's use a Python for loop to loop through all the IOCs in our attributes dictionary. Here we use a dictionary comprehension to create a new dictionary with only IOC value and type. We then write this row into the CSV file. An important point here is that you always want to wrap API calls in a try and except block in Python, because sometimes the IOC may generate a Unicode encode error exception if it includes weird characters like Russian domains or URLs. Let's now run this code and check out the CSV file that is generated. Here we have all our IOCs in the format of type and followed by value. These are all ready to be uploaded to your security tool. You can find this code in the description of this video. If your security tool has an API that can be used to upload IOCs for blocking and detection, you can skip creating a CSV file to manually upload it, and instead you can automate the entire process from pulling IOCs from your MISP instance to uploading them to your security tool. In this demo, we will use the Endpoint Detection and Response, or EDR tool CrowdStrike Falcon, because it has an API that you can use to automatically upload custom IOCs to its IOC management feature for detection and blocking. The following code uploads a single IOC to CrowdStrike Falcon for detection and checks to see if it was successful. This code performs several actions. First, it imports the falcon.py Python module to connect to the CrowdStrike API using Python code. It then connects to the API using a client ID and secret. You need to change the client ID and client secret variables to match your environment. Next, it creates a list of platforms or operating systems that this IOC should be detected on. Next, it creates an expiry date for the IOC so that it is automatically removed from CrowdStrike's IOC management feature when it becomes outdated. This is in UTC format and is 90 days. Then it creates the IOC to upload, defines the IOC type. In CrowdStrike, you can only detect IOCs that are either domains, IP version 4 or version 6 addresses, and MD5 or SHA-256 hashes. Then, the code uses the CrowdStrike API to upload the IOC created using your previously defined configuration parameters. Then, it checks the response returned by the CrowdStrike API to determine if the IOC was uploaded successfully, and then prints the relevant output. The retro detects option seen in the code will go back in time to trigger detections if an IOC has been seen by CrowdStrike in the past. By default, CrowdStrike retains 90 days of logs. You can use this code to loop through the indicators you export from your MISP instance to add them to the CrowdStrike Falcon IOC management feature. CrowdStrike will then detect if an IOC is seen in your environment and generate an alert for your security operations team to investigate. You can adapt this code to whatever security tool you use. For instance, you could use SentinelOne's API to do the same, or you could even use Microsoft Sentinel platform to search through a SIEM solution and do the same for IOCs in there. Again, you can find all this code in the description. Exporting IOCs from your MISP instance is crucial. It allows you to make your threat intelligence actionable and help your security operations team do their job. Doing this programmatically is essential for small teams. The next installment in this series explores how to share intelligence by connecting your MISP instance to someone else's. Information sharing is a fundamental feature of MISP that will allow you to become part of the wider intelligence community.